back to the part 2 of this video. When we started this video, we started looking at factor theorem. Alright, but before we go into the part 2, this is mathematics, and as you know, this is your complete online school of mathematics. What we do here is to break down mathematics and help you understand it, help you get better at mathematics. I am Pendulum, and I'm your tutor on this channel, and it's my joy to always be here to help you understand different topics under mathematics at O and A level. All right, so we'll be going ahead with this video, and like I always say, please don't forget to subscribe, especially if you're new to the channel or if you've been here but you've not subscribed. Just hit that subscribe button, it won't cost you anything, and also turn on our notifications, ring that notifications bell, so that whenever we have a new video up, you'll be notified to come and watch and learn something new. Also, don't forget to share this video with your friends, copy the link, put on your WhatsApp status, share to anyone you can share that you know will need mathematics in their studies. All right, so let's go on. In the last video, in part 1 of factor theorem, we were able to solve example 1, where we verified that x minus 2 is a factor of this cubic function. That was what we did here, and we verified that by division. So in this video, we are going to focus on example 2, which says that given that x plus 3 is a factor of this, and we are told that x plus 3 is a factor of this cubic polynomial, x cubed plus 15x squared plus 71x plus 105. The question now is for us to factorize p of x completely. Factorize p of x completely. Now, what does this mean? Let me just state this. First of all, let me move this thing up so we have a blank state to work on. Or instead of that, I'll erase this side. Let me move it. Okay, so we have a blank slate to work on. Good. Now we're asked to factorize this completely. What does this mean? Now, generally, the degree of a polynomial determines the number of factors that polynomial we have. The degrees of a polynomial determines the number of factors that polynomial we have. So, or the number of solutions that polynomial we have. So, for instance, if you have a linear polynomial, for example, 2x plus 1 equal to 0, this is a linear polynomial, and this question or this polynomial is in degree 1. Because of that, it has only one solution. The value of x here can only be one thing. All right, it has only one solution. You can solve it to know the value of x, but x here should be minus half. Now, for a quadratic equation or a quadratic polynomial, example, maybe something like this, for instance. Now, the degree of this is 2 because it's quadratic. And what that also tells us is that x here has 2 possible values or 2 possible solutions. And if you know anything about mathematics, then you know that whenever you solve a quadratic equation, you are likely going to get 2 answers because the degree of this polynomial is to the power of 2. The same thing happens to a quadratic polynomial, just like we have here, p of x. This is to the degree 3. And what this tells us is that if we solve this polynomial completely, we are going to get 3 answers or 3 solutions. All right. Now, in this question, they've already given us one factor or one solution, which is that x plus 3 is a factor. All right, that means one of the factors of this is going to be x plus 3. Remember, I told you that since this is degree 3, it's going to have 3 factors or 3 answers or 3 solutions. And they've told us that the first solution, let's call it x1, is what? X plus 3. So this is the first answer. We are now asked to factorize it completely, which means we are to look for x2 and x3. So x2 we don't know, we can call it x plus a. All right, and x3, which we also don't know, we can call it x plus b. So these 3 are the complete factorization or the complete answers to this question. X plus 3, they've already given us that. Then we have to look for the next 2, the values of a and b, that will help us get the 3 factors of this polynomial. Such that if we multiply all these 3 factors, it will bring us back to this polynomial. That's what it means. So if we multiply this, and this, we should get back this polynomial. Now the question now comes, how do we look for the other factors of this polynomial? Now, the way to solve this is actually, there are 2 ways, and we'll look at that in subsequent videos. But for now, what we are going to start with here is we are going to divide. All right, now since we know this is a factor of this, since we know this linear polynomial is a factor of this cubic polynomial because they told us, that means if I divide this cubic polynomial by this linear polynomial, I am going to get a remainder which is 0 and a quadratic equation. Basically, this is going to reduce to the power of 2. And if you look at this previous example we did here, you will see that when we divide this polynomial, which is in power of 3, this cubic polynomial by this linear polynomial, the answer we got up here is a quadratic equation. The answer reduced from power of 3 to power of 2, right? So if we can still do this to example 2, and by so doing, we reduce that equation, this polynomial, from a power of 3 to a power of 2. And if we get an equation that is in a power of 2, is a quadratic equation which we can solve by any of the means we have studied. When we solve that quadratic equation, we'll get two factors, which is what we are looking for, right? So let's go ahead and solve this. Remember, we are going to start by division. So step one, we'll divide. Step one is going to be division. So let us divide. We are dividing x cubed plus 15x squared plus 71x plus 105. And we have to divide this by x plus 3, right? So let's do this division together. I'm going to leave this here so that we can refer to it later. So let me leave it there for now. Or can I move it? No, let me just leave it where it is. Alright, so let's go on. Now let's do this division. If you watched the last video, then you should know how to do this division, right? You should know how to do this division. Like I said, you only divide each of the first terms for the bigger polynomial or this cubic polynomial by the variable in the linear polynomial. And then when you're multiplying, you multiply everything. What that means, I'll use a line here to illustrate for the last time. We're going to divide x cubed by x. That's what that means. All right, so let me divide x cubed by x. And if I'm dividing x cubed by x, of course, the answer is going to be x squared. So I'll be left with x squared. X cubed divided by x is x squared, right? Now I'll use x squared to multiply everything here. So x squared is going to multiply this and also multiply this. So I'll use x squared to multiply everything here. X squared times x is x cubed, right? And x squared times 3, of course, is plus 3x squared. Now we subtract because it's long division. X cubed minus x cubed is 0, so that one goes. And then we have 15x squared minus plus 3x squared. Of course, minus times plus is going to be minus, right? So 15x squared minus 3x squared is 12x squared. All right, then I bring down these two. So plus 71x plus 105. All right, now we'll go again. We're going to divide this first term again by x. All right, remember that, please. So 12x squared divided by x, of course, x will cancel one of the x here, so you're going to be left with 12x. Please remember that, 12x. And then you now use this 12x to multiply everything here. So 12x is going to multiply x, 12x is going to multiply 3. And if we do that, 12x times x, of course, is 12x squared. And then 12x times 3 plus times plus is plus. Of course, then 12 times 3 is 36x. Then again, we subtract. 12x minus 12x is 0, so that one is gone. Then we have 71x minus plus 36x. Of course, you're going to do minus times plus here, which will give you minus. So 71x minus 36x, ultimately that's going to be 71 minus 36. And that should give you, I think that should be 35, right? I hope I'm not wrong. Yes, 35x. So this will be 35x. Okay, and then I bring down this last one plus 105. Now again, for the last time, we'll divide this by x. All right, so I'm going to have 35x divided by x. Of course, x will cancel x, so we're just left with plus 35. And then we use this 35 to multiply everything here. 35 here will multiply x, 35 will multiply 3. So 35 times x is 35x. 35 times 3 is 105. Of course, if you subtract here, 35x minus 35x is 0. 105 minus 105 is 0. So you can now see we divided this and we got 0 as our remainder, confirming what they told us, that x plus 3 is a factor of this, because now we see that our remainder is 0. All right, but now we can now see that this big polynomial x cubed plus 15x squared plus 71x plus 105 can be broken down into x plus 3, which is one factor, and then the answer we got up here, the quotient of our division, which is x squared plus 12x plus 35. All right, so this big polynomial can be broken into these two. X plus 3, which is the first factor, which is linear. Now, is linear means it's at its lowest form. This first one cannot be broken further. But now, this second one that we got as the answer from our division here, the quotient of our division up here, is the second part of this. And because it's quadratic, we can still simplify it into two smaller linear polynomials. All right, so the remaining two factors that we are looking for, we are going to get it by solving this quadratic equation here. All right, so that's what we're going to do now. So to find the other two factors, we are going to solve this quadratic equation, x squared plus 12x plus 35. All right, okay, I'm going to remove this so that I have enough space to solve. Of course, like I said, we've done this on this channel. You can solve this by factorization. You can check if it's solvable by factorization. You also check if it's solvable by completing the square. Every quadratic equation is solvable by completing the square. So, and you can also solve it by almighty formula. Okay, so how do we check? Let's start with factorization. And how do we check if it's solvable by factorization? Well, I'll just rush through it. If you want to learn and understand it, please look for the playlist on quadratic equations and watch how to solve by factorization. But basically, if you multiply the coefficient here 1 by this constant, you get 35. Then you look for two factors of 35 that will give you 12. And those two factors are 5 and 7. 5 times 7 is 35. 5 plus 7 is 12. So the two factors that we need here are 5 and 7. That means replacing this by the factors. Please, I'm solving this assuming you know how to solve by factorization. If you don't know how to solve by factorization, please go and watch our video on quadratic equation by factorization. If I replace this with the factors, I'm going to get something like this. Okay. I'm going to have this, and then I can now solve this by grouping. So I have x squared plus 5x. On this side, I can factorize it here and bring out x, which is common, and I'm left with x plus 5, right? And then this second bracket here, 7x plus 35, of course, plus 7 is common. And if I bring up plus 7 from here, I'm left with x plus 35 divided by 7 is 5. All right, I believe you understand what I'm doing, so I'll just go ahead. Now, of course, I'm going to, we have x plus 5 here, we have x plus 5 here. So I just pick one of them, x plus 5. Then the other one is x plus 7 equal to 0. Okay, so you can see that by factorizing this quadratic equation, we've been able to break it down from a quadratic equation to two linear equations, which are 5 plus x plus 5 and x plus 7. All right, so at the end of the day, we can now write that this quadratic, this cubic polynomial that was given to us, which we had initially broken down into this first one, x plus 3, which is a factor, and then this quadratic equation, can still be further broken down into x plus 3, that's the first factor they give to us, and then x plus 5 and x plus 7. All right, so this is the complete factorization of this question. X plus 3 times x plus 5 times x plus 7. This is the complete factorization of this equation. All right, so you can see it's simple. First thing you need to do, as far as you know one of the factors of that cubic polynomial, as far as they've given you one of the factors, you use that factor to divide the cubic polynomial so that you can reduce it from a degree 3 polynomial to a degree 2 polynomial or a quadratic equation. And then you factorize or you solve the quadratic equation to get the remaining two factors. All right. Now, remember here they asked us to factorize completely. So that's why our answers are in this form. They are in form of factors, x plus 3, x plus 5, x plus 7. Now, what if they ask us to solve it completely to get the answers, not just the factors, but to get the complete answers of this? Well, it's not difficult. If you have the factors, it is very simple to get the answer. Now, our first factor, x1, is what? X plus 3, right? That's this. This is x1. This is x2. This is x3. Now, this is x1. If we're asked to solve it completely, it's very simple. All right. All you need to do is just say x plus 3 is equal to 0. And of course, this plus 3 will cross to this side and becomes minus 3. So therefore, x is equal to minus 3. x1 is minus 3. That's the first solution. x1 is minus 3. Then x2, the second solution, we have x plus 5 equal to 0. And therefore, if this plus 5 crosses to come here, x2 will be minus 5. And then finally, x3, we have x plus 7 equal to 0. And then you see in the same vein, x3 is minus 7. So if you're asked to solve it completely or find the complete solution, once you factorize this, you don't have a problem. Just put everything equal to 0. The first one equal to 0, you move, collect like them. Second one equal to 0, collect like them. Third one. So the complete solution here is that x1 is minus 3, x2 is minus 5, x3 is minus 7. All right. But here we're not asked to solve it completely. We are just asked to factorize it completely. And this here is the complete factorization of this question. All right. So I hope this was clear enough and you understood what we did here. It's not difficult. It's not difficult. Just follow and understand. So I'll give you an assignment now. I'll give you an assignment now, and to test if you've learned this. So please, like I always urge you, make sure you do this assignment because it's going to help you practice what you have learned. Looking at it, you may think you understand, but until you do the assignment, that's when you're actually sure if you understand it properly. All right. So this is very similar to what we just solved. This is very similar to what we just solved. They are given a cubic polynomial here, and they have given one of the factors. All right. So we are asked to find the other two factors. What you just need to do here, like we did, divide this cubic polynomial by this linear polynomial. You get a quadratic polynomial as your quotient, as your answer. Then that quadratic polynomial, you factorize it and get the other two factors. All right. So do it. Put the answer for me in the comments or send it to me on WhatsApp, and I will let you know if you're correct or not. In a few days' time, I will make the solution video to this assignment and put it on the channel so you can also use to check if you were correct or not. All right. So thank you. The next video we'll look at another aspect of factor theorem. Now, if you look at these questions, you are given one of the factors to solve. All right. So they've given you one of the factors. They're asking you to find the other two of the other three factors. The other two factors, sorry. But what if you are not given any factor? What if they just give you this cubic polynomial and they ask you to find the other factors? What do you do? So that's what we'll look at in the next one or two videos. All right. So till then, I remain Pendulum. Please don't forget to subscribe to this channel. Very important. Subscribe and hit that notifications button so that you'll be notified whenever we have new content up on the channel. All right. Tell your friends about this channel. Share the link with them so that they can also subscribe and they come here and learn. Thank you very much. Like this session, drop a comment, subscribe, share. God bless you. I'll see you in the next.